Welcome to a special episode of the Quality During Design podcast. This episode is part of our interview series called A Chat with Cross-Functional Experts. Our focus is on speaking with people that are typically part of a cross-functional team for new product development. We discuss their viewpoints and perspectives regarding new products, the value they bring to new product development, and how they're involved and work with product design engineering teammates. Today, I'm talking with Adam Bahret. He is a reliability engineer involved in new product development and business systems, and I wanted to get his viewpoint and take of reliability engineers and how they work with product design engineers. We talk about the importance of a business culture that supports reliability engineering endeavors, but we also get into what product design engineers can do with reliability engineers as they're developing products, what kind of questions reliability engineers can be approached with, what kind of answers they may be able to provide, and the value that they bring to new product development projects. Now, let me tell you a little more about his history and how he serves his customers. He's the founder of Apex Ridge Consulting and a leading reliability expert who writes, speaks, and coaches executive teams on reliability as a competitive edge. His reliability culture change program has delivered millions in savings for his clients while mitigating risk and forming a foundation for reliability-fueled growth and brand dominance. His clients range across multiple industry segments, including medical devices, robotics, semiconductors, aerospace, consumer, and automotive. Adam works with technical teams to improve the design while mentoring leadership teams in adopting the processes, language, and behaviors to build a reliability culture. He also introduces key reliability metrics such as time to reliability. That guide organizational thinking and build a robust reliability culture that's the hallmark of dominant, top-performing technology companies. Adam is the author of 2 books on reliability engineering, with a third on the way: Reliability Culture, How Leaders Build Organizations That Create Reliability Products, and How Reliable Is Your Product? 50 Ways to Improve Product Reliability. Adam's third book, Devastate the Competition, will be published in late 2023. This book covers how the business objectives and reliability program can be connected to create an unbeatable formula to dominate your product's market. Adam has deep technical expertise and over 25 years of experience in product development and reliability engineering. He has a Master of Science in Mechanical Engineering from Northeastern University, is an ASQ nationally certified reliability engineer, and an international speaker on technology, leadership, and product development. More information on Adam and Apex Ridge can be found at apexridge.com. Now that I've properly introduced you to Adam, let's get into the interview. Hi, Adam. Thanks for joining us on the Quality During Design podcast.
Hi, Diana. Thanks so much for inviting me. I'm looking forward to this conversation.
Me too. I'm really excited to talk to you today about the viewpoint of reliability engineers in new product development. Can you tell us a little bit more about your reliability engineering career, the kind of projects you work on, and how you get involved with new product development projects?
Yeah, absolutely. I mean, I've been involved specifically in reliability for over 20 years now. My career started off in mechanical engineering with a heavy focus on finite element analysis and using computer modeling to improve mechanical systems through structural, thermal, vibration. I then got into the physics side of it, where I started doing electrostatics, ion beam, in vacuum, magnetics, and really enjoyed that. And then began to see how testing was really how critical that was to anchoring the analysis and having it, work in kind of concert. So I really discovered reliability and how amazing the test and analysis tools were early in the design process, and ended up building a reliability engineering department in the ion implant company I was working in, and really fell in love with it and saw how it can help the design process early on. You create the best design the first time.
So you actually built a reliability engineering department within the company that you were working for. There hadn't been one before.
Exactly. Yeah. Yeah. And a big company too. But Their technology moved so fast, reliability wasn't as much a critical part of their sales, because when technology is moving fast, customers want the latest, greatest, and that increases profit enough, especially when they're using it in production. So the customers were companies like Intel, Motorola, making microchips. So if the ion implant process could be faster or have new features, even if the reliability was worse, it still was worth it. So, but as technologies mature, reliability becomes more and more of a competing factor, and that's what was happening. So built a reliability department, built internal labs, kind of built up the team to about 12 people. But, of course, that also began my journey of what I call reliability culture, where I got to really understand how difficult it is to have the design for reliability philosophy be part of the design process. And this being that, is the ownership really shared with the design team? After that, I went to a medical company. It was a 50-year-old medical company that their reliability work was kind of scattered in their different departments, and they wanted to consolidate it. So I went there and created a consolidated reliability department, same thing. But I also realized I had an addiction to creation. And I didn't want, the reason why I left the first was that I didn't want to just run a department. And I also knew I didn't want to be an executive. I didn't want to run up the chain of command. I'm an engineer. I always wanted to have some part of that in my work. Same thing at the second company. Once it was up and running, I was like, oh, I want something new. And that's when I left and started Apex Ridge Reliability, 10 years ago now. And since then, I've helped, tons of companies, everything from Amazon Robotics, Boeing, Hyundai Motors, Keurig Coffee, lots of medical companies, Medtronic, all make the most reliable version of their product the first time. But what I also did is I always saw that element of the way that they were structuring their product development programs and their organizations were not getting the most from it. So my first book was How Reliable is Your Product? 50 Ways to Improve Product Reliability. And this looked to address that by taking the Design for Reliability Test and Analysis Toolkit and describe it in a way where anybody with any technical background could understand it. So all the other engineering disciplines.
So that was a way for you to try to communicate the value of reliability during product development. If they were supposed to understand it, they needed to understand it. And so many of the reliability books were written for reliability engineers. So kind of keeping going that isolation. And so they needed a book they could pick up, and it just made sense and was written from the reference point of what they were trying to accomplish. But then as I progressed farther, my second book, published by Wiley, Reliability Culture, directly addressed how leadership can change how their technical teams operate to make the reliability functionality just be part of their role in what they do. And that's kind of been my quest since then. And the two ways I work with my customers is I work directly with the engineering teams to help them incorporate design for reliability and the toolkit and to understand and learn them. But the second way is I work with leadership to help them understand how they can change how they set up their organizations, how they set up their product development programs to get the most from the design for reliability toolkit. So you're speaking with somebody who really has very enthusiastically tried to carry the torch to take the reliability engineering discipline and take it to this next stage where it's grown through so many different iterations, going back to the 1960s when it was just statistics really, but driven by the military. Mm-hmm. In the 1980s and 90s is when design for reliability, the idea of, wait a minute, you can't design something and test in reliability later, you have to design it in. And I think this new chapter really is this reliability culture part where the entire company, including leadership, really understands the principles and how they need to be part of the structure of the organization.
Your story sounds a little similar to other reliability engineers I've talked with in that you are approaching it two-pronged, that you first started to try to build in engineering within the team, reliability engineering within the team, so that the engineers would understand and do outreach for that. But then you realize that leadership also needs to be a part of that, and you incorporated that later. For product design engineers and new product development, I guess there's a couple of things that they could do. They can learn more about reliability engineering to incorporate it themselves. And they can also talk with someone like you, a reliability engineering expert, or bring in a consultant to help. So what are some of your directions or steps that you would recommend a new engineer or someone that wants to incorporate more design for reliability? what are some of the next steps that they could take toward design for reliability?
I think the most fundamental shift I see to get people going in the right direction is when the design team understands that it's part of the design and part of their responsibility right from the beginning. So as an individual engineer, this can be a hard thing to campaign for. You don't really have within your responsibilities the opportunity to drive those changes. It's something that has to happen at a higher level. So really the best thing is for any individual engineers to talk with their leadership and share with them how, if they were to do this, they would be in a better place, because leadership's the one who ends up holding the long-term accountability for the product. So when the product gets released, so often the design engineers are congratulated. They got it, they designed the new features, they got it out on time, and then they move on to the next project. And leadership's left dealing with a year later, everything not going as planned, a lot of warranty expense, angry customers. It's affecting next generation sales because they're brand damage. So I think if a newer engineer understands the value of design for reliability, what they should do is be sharing that with leadership and helping them connect it to their business accountability. Because that's really where the value is, right? It's the return on investment. What do we get for including these reliability tools in the process? Because without seeing exactly how it generates value down the road, it's a hard thing to negotiate for, because when you say, I want to do this testing, or this testing found this issue, if everybody's only focused on time to market, that's a hard thing to push against, right? It's difficult to say, I want to investigate if this could be a failure mode that shows up later. And everyone else is like, we got to get this thing out by July. Like, you don't understand. That's our deadline. But if you can help them understand, you're going to get it out by July and then have a 6-month recovery phase because of field issues. But if you just give this extra month to do this testing, you won't have that. That's a gain, right? It's a net gain in so many ways, not just the time to market, the true time to market when it's done, but in the brand damage, in not having that 6 months of engineers not developing new products because they've gone back to fix the old one. And I think that's such a fundamental concept that I eventually created a term for it, because I felt that if you don't name it, it doesn't exist, right? Mm-hmm. So we have time to market, but I came up with the term time to reliability, right? And this is the true metric of a project being complete. And you could decide what measures and time to reliability, whatever works for you, but it could be something like that's when 90% of the development team is no longer working on the project in any form. These kind of metrics that are implied by time to market, right? That's when the budget drops off to XYZ. And that's your true measurement of completing the project, not this kind of phantom pretend fantasy date that you've satisfied just because you got a prototype out there that barely works. So once you start really measuring time to reliability, which includes the recovery phase that you have and measures it in dollars and measures it in time, if that's getting measured, all of a sudden you can really calculate the return on having implemented those tools earlier in the product development process.
When you develop these reliability engineering teams at these other companies, did you find you needed to do a little more research or connect the dots between what the reliability engineering department was able to do and what the long-term effects on the business was? Did you have to sort of prove that out and kind of have a background drumbeat of reliability engineering is producing these results for the company before you could introduce this time to reliability concept? Or did you go right away with time to reliability and start collecting those kind of metrics?
Well, one thing that's different about my situation than the design engineer within an organization is leadership obviously already has an awareness of it and beginning to understand if they brought me in, right?
Okay.
So that's a little bit, it's a little different than if you're, somebody in the audience is a mechanical engineer who sees the value of this and wants to promote it. You have to still go through that first stage of getting people who will champion it. By the time they've engaged with me, leadership's already wanting to listen to what I have to say, right? They're paying for my time. They brought somebody in. They're looking for a return on investment from my time. So when I'm advising them, they're listening, right? It doesn't make sense to bring me in and then ignore me. For me, then, that's why things like time to reliability and creating these concepts, I try to regularly create new concepts, to help people understand who aren't as close to it. I think that helps right away, help them frame some of the things they've been feeling and thinking, and then put them into motion, right? A leader who sees the problem is wondering, like, I can't take this. I can't have 20% failure rates in this new technology. I mean, our competitors are just going to come and steal our technology, make a reliable version and take it. It's personal. They're going to lose their job eventually if the bottom line, they're losing money. How can you develop new technology when nobody trusts your brand? So when something like time to reliability is introduced, that helps them actually say, well, let's make that quantitative. And now you can make quantitative decisions mid-program if something's a worthwhile investment. That is a big difference because they already are looking for that. Mm-hmm. So leaderships, obviously this is happening at their level. So you're going to have to do everything you can to get leadership to see if they understand and are willing to make those connections. And I think they'll be very eager if you help them understand, because it is something that is of probably more pain to them than it is to the mechanical engineer, right? The mechanical engineer or electrical engineer, they will have some accountability, for something not working as intended, but that's shared amongst the team and a broader audience. And they will generally, unfortunately, leadership undermines their own objectives and measures everybody on developing a feature in time to market. So you will get rewarded. You did what you were supposed to do. And the funny thing is that when things go wrong a year or two later, sometimes those same engineers, design engineers, get brought back as heroes to save the day, right? So you, strangely enough, are getting rewarded for poor reliability. So even as a reliability engineer, if you made me a mechanical engineer in programs like that, I'd be, why would I focus on reliability when my initial rewards are time to market and developing a feature? And if I don't hit my time to market, I get in trouble. So I need to cut out as many tools and, maturing processes as possible. And then a year later, when things go wrong, I'm considered the only person that can figure it out and save the day. And I get a ton of visibility with the executives as they're urgently, they want every week, they want an update, and there's a bit of a celebration when it's solved. So I'm working within a construct of incentivizing to not focus on reliability, even if it's a thing I'm most passionate about. So that's why it has to start with leadership. They have to change how they structure the organization and the programs, right down to what are the metrics, what are you connecting to people's personal performance, evaluation. When you do that, things kind of begin to naturally redirect towards making a more robust product the first time.
Yes, I'm hearing you say that that leadership is key to a robust reliability engineering program. Let's switch gears a little bit to, instead of product design engineer working in a company that recognizes they want to implement more of this and working through leadership, let's instead look to maybe a different company that there is a reliability program. Maybe it's new, maybe it is not so quite intimately intertwined with the new product development process, but there is a department and there are reliability engineers there to support the new product development project. When an engineer is working on a new product, when and what kind of questions would they approach the reliability engineering department about? Sometimes it's waiting until you have something you can actually test, but it's been my experience that you want to involve the reliability engineers earlier. So I'd like to hear what you think about that and what kind of things reliability engineers can do to help the product development process as they're working on concepts.
Yep. Yeah, I think one of the most fundamental shifts in how a design engineer goes from being an individual who just wants to invent from an individual to being an individual who wants to make a robust product the first time. There's a really simple principle, and it's fail fast and fail early. And that's so different from what a design engineer wants to do instinctively. Design engineer is going through this process of creating something. When you create something, you want it to work. And if you're testing it, you want it to pass, right? When you hear the word test, you naturally think pass. I want to pass a test. That's great when you get to the point of having a prototype work. That mindset will, undermine your greater objectives if you keep it continuing to go forward. Because if you keep that mindset of I want it to work, you're going to be doing testing that facilitates it to pass. You aren't going to be trying to find failures. You're going to be trying to have it successfully run 10,000 hours or whatever you need. So the shift here is, and the reliability mindset in design is, whether you see the failures or not, they exist. Whatever those 1,000 first failure modes are for your design, they exist. And over enough time, they're going to be discovered. What you are frantically trying to do is see as many of them as possible in that short time frame you have this design in your hands. Because the next reliability engineer, test engineer is the customer, and they're going to find the rest over a long enough time frame. So what success at that point, after you get the prototype to work, is having it fail as many ways as you can. And this is where a lot of the design for reliability toolkit comes into play. And this is where the reliability engineers can help. The reliability engineers should understand, okay, we want to do halt testing and use halt testing to expose as many failures as we can in a very short time period. Halt testing 3 days. I mean, you can, with about $6,000 worth of lab rental time and 3 days, generate a whole bunch of failures in your product that may or may not be associated to your use case. They may be from stresses far beyond your use case, but they will be failures nonetheless for you to study. And each failure is telling you something about the design. These are design characteristics and will inspire ways to make the design more robust. So it's the design engineer taking that moment to flip that switch in their mind of, that's great, I got the prototype to work. Now I'm a detective trying to find those failures that are going to show up in the field, which means I have to cause failures. And that's when, if you engage the reliability team in that mindset, there's nothing but success that can happen in a very short time frame.
Now, is it helpful when the product design engineer is maybe they don't have a prototype in hand yet, but they're starting to think about the types of components and the modularity of whatever the system is going to be, and maybe the geometric layout of how it's going to be set up? Are those important conversations also to have with the reliability engineer?
Very much so. If you are waiting to test until you have a complete system, you're very late in the program to be suggesting changes, to be even getting units you have enough time with before the product goes out the door. The business side wants, after you have a prototype working, to put it in production, right? Let's get it out the door. So the more test and analysis tools you can implement earlier in the program before a whole system, the better. Because you can, one, the tests are usually less expensive and simpler because you have sub-assemblies. And two, you're early enough to where you can do a lot of iterations. I mean, if you're generating information about failure modes and how the design performs, that's not of any value if you can't use that information to explore making the design better. So how do we, enable this to where you can, as early as possible, do it? Two things. One, you need goals at the subassembly or component level. Saying that our high-level product has a 99.99% reliability doesn't mean a lot if I'm designing a small gearbox with a motor. What's my reliability? It's not that. It's some much higher reliability, because all the reliabilities put together, it greatly reduces the high-level reliability of the system. So my reliability is some other number. So even if I was to test, what's my goal? So we have to generate goals for subassemblies and components. So the way you do this is allocation modeling. An allocation model is where you take the highest level goal and you break down the system by functions and then allocate subsystem goals. And what you end up with is a model where all the, I like to describe it as parent, children, and siblings. All the children at all levels are going to support that high level goal. So a lot of things can happen here. Is one, you have an initial goal to try to test to, but then if you don't satisfy that goal, there's a lot of options of what you can do. One can be to redistribute the balance of the allocated goals, right? You might have a sibling who's way stronger than they have to be, and they can allocate some of their goal to the weaker sibling, right? So still the parent still experiences the same sum of those. Or of course, you can look to redesigning to make it better, or you might see an opportunity for parallelism, for redundancy, where you can discover like, all right, to invest in this little technology, this whatever, I'm just going to say a resistor or a capacitor, this capacitor to design one that hits the reliability goal we need, we're going to have a whole capacitor R&D program. And that's not what we do. That's not our technology. And we don't have time for that. What if we just put another capacitor in parallel that if one fails, the other can take the burden, That's when you look at the math of that, that's extremely powerful. And now you're doing that early on, very early into the first iteration of the design. And this also is a big deal with suppliers, right? Because you have a lot of options with suppliers to pick. You can pick their base model, their value, component, or their gold-plated one. Which do you need? So when you've allocated goals, now you have goals for your suppliers and their components, and you can start to talk with them and try to find suppliers who've done good reliability programs and can demonstrate that they can satisfy those goals. And you can find out, what fits best. So now that we have those goals, we can do lots of much more simplified bench testing and other tests. If I have a gearbox and a brushless motor driving it in a simple controller, and I want to test 20 of those, that's much easier than testing 20 of the full bigger, let's say it's a robot system that, has all this complexity, and asking for 20 of those later in the program, you're just going to get a no. That's not happening. That's not even a smart business decision at that point, right? You'd be delaying the program to a degree that could really be pushing in the urgency of get to market. But asking for 20 small gearboxes, people will be like, sure, whatever, and you're not testing the whole robot outside. You just have gearboxes spinning on a bench, yeah, sure, buy more wood benches. We don't care. So, by doing that, you're really facilitating that fail fast, fail early strategy, because you've taken it all, one, set specific goals to aim towards, and you aren't just testing in a kind of open-ended, aimless way. And two, you've made it very simple and expensive, and you can get enough samples to have good statistical significance.
And you're also kind of touching on cost too. A lot of people think, if we need to do reliability testing, that's just going to add to the cost to our project. Whereas if you do the early concept work, like you're describing, with your changing your mindset and setting reliability goals and doing those tests on smaller things, just the cost of the products that you want to test is going to be less. Maybe the type of reliability test cost would be less. And then you also mentioned working with suppliers, and if you're going to go with silver, gold, or platinum versions of a product, that could also introduce cost savings in the long term too. Do you have any additional thoughts about costs and doing reliability things earlier?
Yeah, no, absolutely. Actually, well, I guess once you write a book, you get addicted to book writing. I have a third book in the works called Devastate the Competition. I'm hoping it'll be out end of this year. And it's very much about connecting the business side to the reliability and design program, right? The first book was about the reliability tools. The second book was about how leadership can structure the programs better. And this third book is, let's just flat out connect it as part of to the business model. Because at the end of the day, what is the only metric that really matters? And it's dollars. I mean, long term though, cost is a big deal, and looking for these ways to have it balance out. It goes back to that earlier point I talked about understanding the return on an investment. So if we are trying to look at what the true time to reliability is, what is the cost after the recovery phase, potential brand damage, all that, and we're looking at individual tools to see, do we want to invest in this reliability growth program? Do we believe it's going to pull in our time to reliability? That's something that you have to, calculate and then discuss with everybody and get an agreement that these numbers are what they are, because they're speculation. But if instead of a huge reliability growth program that costs $100,000, that you say is going to save $1 million later, you're like, oh yeah, no, I have a $10,000 program that'll save $1 million. That discussion becomes a lot shorter. People can debate, no, that's a $12,000 test program, or no, you're only going to save $800,000. Like, so what? It's still just a smart investment at that point. So when you bring cost to it, it really helps with those mid-program discussions. And There's another dynamic shift I look for here. We don't want to be opposition. We don't want it to be reliability versus engineering. We don't want it to be reliability versus leadership. What we're looking to do is switch to where we're advisors. We're all working towards the same thing, but we're bringing an expertise that can yield really great input and advice to help leadership make the best decision. So if you switch to that advisor mindset, it's really different. And the way you have to do that, though, is bring more quantitative type of metrics and measurements for investment, which leadership's the way that they quantitatively measure things is dollars. So the more you can connect it to dollars, the more you become an advisor, helping them make good mid-program decisions. I think that's kind of if you can measure your performance in that, am I an advisor or am I just campaigning and whining? Because otherwise it just sounds like, we need more test time, we need more units. And they're like, you always say that, like you just always are saying that, like we just ignore you. It doesn't. Whereas if you say, well, I believe if we invest in this $12,000, bench test program, and it'll probably take about 3 weeks, I bet it could only really extend the program by a week and a half because I can overlap it with other stuff. But if I point to, you remember our last product release where we had that issue with the gearbox and we had to send people in the field to figure it out. And then we had to do a redesign and a retrofit. And the customer was angry and those engineers weren't working on the new thing. How much do you think that cost us all? And it's easy to be like, well, that was $1.5 million. Like, you don't have to say anything else after that. You're like, I'm proposing a $12,000 thing that might extend the program a week and a half. That's going to save you what you just said is $1.5 million and 6 months of misery. All you've done is advise them and help them make a better decision. So when that becomes the dynamic between the people in the organization, that's when I'm really realizing like this is succeeding.
So it sounds like when product design engineers are working with the reliability engineers to make those decisions, because they are also held to some cost limitations on the types of materials that they use or the suppliers that they choose and the components they pick. A reliability engineer could be a partner in making those decisions from a reliability point of view, but then also a costing point of view with respects to the kind of tests and then the overall reliability. Is that correct? Is that what I'm hearing too?
Yeah, that is correct.
So there are a lot of ways to partner with reliability engineers for new product design. We've talked about quite a few of them. I like that you mentioned switching your mindset to looking for failures, because that is an important distinction. When you are trying to build something and create something, you do want it to work, but you also want to look for the failures. That switch has to happen. I like that you said it like that.
Yeah, I call the principle. So I wrote an article about it called Robust Ready and Risk Guidance. It's on my site. You can find it on LinkedIn or you can find it on my site. Well, I guess my site's apexridge.com. And the Robust Ready Risk Guidance principle is part of a higher level principle I have called lightning fast reliability. And the idea is simply this. Robust ready means you're doing everything you can to have the design be as robust as possible, as early as possible, have it be ready for the next stages of the program. And the way to do that is switch that hat from being the loving parent designer to the rough, mean coach who just wants to beat the hell out of it and and make it everything it can be as early as possible. It kind of is that, right? If you picture somebody who's successful in life, you look at their childhood, you had the nurturing, caring mom and dad, but if they developed themselves, they also did sports and, other things. And coaches weren't as nice. Coaches pushed you, they helped you, they pushed you through failures. They had you fail. They had you discover your limits. That's how you grew. And it's that concert of those two things that really can, create fantastic development. So to some degree, you have to see if both those roles are there for your child, your product design. And maybe it's you playing both. Maybe maybe you are the parent who also coaches baseball, right? And you take off your dad hat and put on your coach hat and kind of be like, what are you doing out there? Come on, And so that's the robust ready idea. And then the risk guidance part of it is, all right, after you've done that and you've done that big push to make it better, we need to make sure that the product is now satisfying all the product factor balance. And the product factor balance is a term I created for all the different elements that are shaping how you want the product to get maximum market share. So it might be that we want a certain cost point, we want a certain time to market, we want to develop certain features, and we need to have this reliability. So the risk guidance part is how are all those factors and measuring against them steering your mid-program decisions? You have to constantly check in with them and use risk, also risk tools like DFMEAs and other elements that actually try to quantitatively take risk and allow them to be more easily incorporated to mid-program decisions. And that's actually, but both those are actually elements in the new book too, because of how well they connect, what you're trying to do from the reliability perspective to the program.
Yeah, I've been involved in quite a few FMEAs, and the more you can use it, not to just assess whatever you've got, but as an input to help you make decisions on what you should do. That is a big benefit and an important reliability tool.
Yeah, it's funny. DFMEAs are extremely powerful, but like anything powerful, you can do as much damage and hurt yourself as you can to do something amazing. DFMEAs done incorrectly are truly devastating. A funny moment I had is a big customer. A customer I had that I say big because it's a household name. You would know them if I said who they are.
Okay.
I had come in and done an education program for them and was beginning to engage in their design product program. And I mentioned DFMEAs and they flinched. And I was like, whoa. And I asked them and they were like, this is the exact quote, and it's heartbreaking. They're like, we've been a bit traumatized by DFMEAs. I was like,
Aww.
Traumatized. I was like, oh my God, what's happening? And they're like, well, they just stop us from getting anything done. And I'm like, what are you doing? And they're like, well, the whole team meets for like between 4 and 6 hours a week every week. And we've been doing that for 6 months. And I'm like, geez, like, that's what you want your competitors to be doing. And I'm like, well, what comes out of the DFMA? They're like, well, when we're done, we did it, we check it off and we file it away. I'm like, so you are taking that kind of manpower, putting it in a mud pit where you can't do anything for that many hours a week and nothing comes out of it. I was like, that's what you hope other people are doing who are making competing products, but and that's what happens. And, but a DFMA done correctly is a phenomenal tool. It really can help guide making the best decisions. That fail fast, fail early, right? DFMEA is like, well, here's the greatest risks. It's pointing you to it without even testing. It's from just the team's technical expertise. It's saying these are the areas that are greatest risk. Start here. And so now that testing you're doing is even more effective because it's more focused. But you have to do a DFMEA correctly. And that means that you have to have trained facilitators. So that's something I do pretty early on is I say there is no DFMEA that's allowed to be done that's not being done by a facilitator. And there's nobody who's allowed to facilitate who hasn't gone through a facilitator training program. And anybody who attends has to go through a general education program. I have Adam's 9 points of effective DFMEAs to start everybody out with and kind of help them get, a few kind of cornerstones. I don't know if 9 cornerstones is a building or not. I don't know. That's but this is really critical that it not be taken lightly because it is powerful, and you can do just as much damage. You can do tremendous damage with that power as you can do good, but that's just a matter of training.
Yep. Especially
every your audience is all dorks. Don't get it. Every Jedi had to go to Jedi school before they were given a lightsaber for good reason. Otherwise, there's a lot of limbs and fingers that get cut off if you start just swinging it around. So
and I totally understand what you're saying, and I'm on board. I don't want people to be afraid of it either. Be afraid of, oh, well, I don't even want to start FMEA or look into it because it sounds too hard. So I do encourage people to learn about it because it is a very powerful and useful tool. Yeah,
I agree. I mean, you shouldn't be totally intimidated by it, but you should respect it, and that
it's a good way to put it.
And that you can. I don't want to say don't be afraid at all, because here was a huge company, tremendously successful, who used the word traumatized because they didn't respect it and the fact that you can't just jump into it.
Mm.
So, there's, I wouldn't say nobody should be afraid of swimming, but I would advise learning the basics before jumping in the water because the outcome can be rather tragic. So, you don't have to have some huge epic, education transformation program before you do it. but get a few good books. I mean, of course, nowadays there's infinite knowledge online. I mean, so if you're going to do it, I would say, and you want to get going quick, I think the steps are this. Identify somebody who's going to be the facilitator, somebody who owns the process and will navigate the team. Give that individual some time to go educate themselves and learn as much as possible, and then get started, right? So, and get going. Don't just start scheduling DFMEAs. That I would say, that's probably where they went wrong, is they're like, oh, DFMEA is something we have to do. It's on our checklist. Let's just all get together and start talking.
Yeah.
And that was horrible. They lost a lot. They should have not done that. That was so much time that could have been used. So respect it, get the basics, be aware that somebody should be facilitating it, driving it, and that person should be educating themselves on best practices and, kind of, I guess, keep an eye on the road. Are we doing something valuable is probably the best metric. A valuable DFMEA is immediately guiding you towards areas to focus on that are of greatest risk and should be driving action. You should be able to see, oh, these tests are being done because of the DFMEA. This analysis is being done. We're evaluating this because of actions out of the DFMEA. That's valuable. You're doing the right thing. Keep going.
Mm-hmm.
Maybe you're not doing it perfectly, but keep going. But if you turn around after 4 weeks of doing a DFMEA, and when people walk out of the session, they never think of it again, there's no actions that came out of it, it's not directing anything, you got to stop and regroup.
Yeah. Now, from your experience with reliability teams, you worked in companies, you set up reliability engineering teams within companies. Are the reliability engineers someone that a product design engineer could approach about help with an FMEA?
You mean outside their company?
No, within their company. They have a reliability engineering department. The product design engineer, I would think, would likely want to talk with the reliability engineer about FMEAs and maybe get some help from them for those analyses. Is that something that you would recommend?
Well,
or is it independent of the reliability department?
No, I mean, if the reliability engineering team are the ones who have the expertise, yes. It's not, I don't care about the title of the person that's an expert in it. It could be the person who also works at the front desk. That's fine with me if they're an expert in DFMEAs, have them help you. I mean, you're just looking for guidance and help from somebody who's experienced. So, if reliability is like, I don't know, if the first person you ask doesn't have expertise in it, go to the quality department, ask them. If they don't, find that, it could be somebody who's now a manager in design who also has a green belt from an earlier part in their career. If they know it, have them do it. It doesn't matter in their role. If it's somebody who has the knowledge that can help you get going, I mean, and this is valuable to the company, have them help you get going.
Mm-hmm.
And if not, just get somebody, outside. I mean, that's why consultants exist, right? I mean, that's kind of the general role of a consultant, is a specialty or expertise that's available on demand for the period of time you need it, right? So,
yeah.
There's nobody inside that knows DFMEAs. We know that if we just jump into it and go, it's likely to not be productive, and we want to be productive. Let's get a consultant and engage them for a period of time to get us going. I mean, that's just a no-brainer. If you see the value of a DFMEA and you don't have internal resource, that's the point of consultants.
Yeah. So we've talked today about the reliability engineering departments getting set up and bringing in leadership. We've talked about engineering teams and how reliability engineers get involved in new product development, how they can help engineers switch mindsets from success to looking for failures, and setting up reliability goals and tests, and even some cost savings. So we talked about a lot about the benefits of talking with reliability engineers in new product development. Do you have any lasting thoughts or a small step or a next step that a product design engineer that's listening to this podcast could take? What would be the next best thing if they're learning something new from our conversation today?
Yeah, I think there's two things there. One is switch your mindset. Understand where you're at, because you're a design engineer when that's a specific set of responsibilities. If you're seeing that you want to help be a part of driving reliability, become more a part of the process, take a moment to see how you can shift your mindset to be there as the reliability kind of, person who's going to help guide. And then secondly, start dialogue with everybody else. You can't do it yourself. Don't pick up the torch as the only person interested in reliability and start running around. That's not going to be very productive. Have a lot of conversations with everybody at all levels of the organization, and get people to begin thinking about it and wanting to participate in it together.
That's good advice. Thank you.
Yeah.
Now, if people wanted to find out more about you or contact you, how could they best do that?
Sure. You can find me on LinkedIn. It's Adam Bahret. My last name is spelled Bahret. My company is Apex Ridge, APEXRIDGE. I'm on LinkedIn. You can go to, obviously, the Apex Ridge website, which is apexridge.com. And yeah, I love to hear from people. I love discussing these things, and more than happy to provide some input if anybody would like to reach out or is interested in helping the organization grow in that way.
Well, thank you, Adam. I really appreciate talking with you today. I think you provided a lot of value to our audience, so I appreciate you.
Oh, good. Thank you. I'm glad. I really enjoyed the conversation.